Okay, let's go ahead and get started. First of all, thank you for joining us today. My name is Kathrine Lord. I am the Global Mobility Lead at Avanade, and I'm here to talk to you a little bit about what we're doing at Avanade. But before I get started, I wanted to actually say thank you to my friends from the Netherlands. Today is National King's Day in the Netherlands, and they brought me this really cool t-shirt that says, with the crown. So thank you very much, and although I'm not wearing it, I am celebrating with you in spirit. So Avanade, for those of you who are not familiar with who we are, we were a joint venture between Accenture and Microsoft, formed in 2000. We have approximately 25,000 employees, and we have about 3,000 C# developers. In addition to that, we have over 200 people that are trained on Xamarin, and we have about 20% of those that are certified. We have a mobility center of excellence that we formed about 3 years ago in response to our Xamarin client demand. And we have 100 developers in our COE, and 30 of those are actually certified. We did over 300 enterprise mobile applications in 2015. We are also an elite partner at Xamarin, and we are a gold sponsor here at the Evolve Conference. In terms of our overall mobility, we were Partner of the Year for Microsoft for 3 years running between 2012 and 2014, and we were the Partner of the Year for Microsoft in 2015. So that kind of tells you a little bit about who we are. In terms of what we're doing, 2015 was the last year that we actually began, that we were actually measuring mobility as a siloed business. In 2016, we moved mobility under our digital workplace practice, which is part of our digital all up. And we actually chose that because what we saw was that many of our customers were maturing in their mobility rollouts, where they had initially started targeting their digital or their mobile workforces, like sales and service folks, with mobility. They were now looking at a larger picture with their entire employee experience. In fact, I know many of you probably saw or heard Satya Nadella say at Convergence last year that it's not about mobility of the device anymore. It's really about mobility of the experience. So at Avanade, we are taking a very holistic approach to mobility today. In fact, we don't offer a mobility strategy alone anymore. It's part of our digital advisory or strategy sessions at Avanade. In addition to having mobility under digital workplace, we also have IoT or Internet of Things under DW as well. A few years ago, Accenture actually introduced what was called CPaaS, Connected Platform as a Service. And for the last 2 years, we've been working with Microsoft and Accenture to port that to Azure. So at Mobile World Congress in February, we announced CPaaS on Azure. And that's a very exciting announcement for us, taking advantage of the Azure IoT services. We also know Gartner has estimated that by 2020, there will be approximately $4 trillion of revenue potential in IoT. So this is a rapidly growing space, really a lot of potential there. At Avanade, we're focusing primarily on industrial IoT, and that's really, we're calling it our digital operations. We've chosen industrial IoT because of the unique opportunities and challenges that are being faced in industries today. And some of those challenges we're going to talk more about as we introduce the demo and what we're working on here on stage. So with that, I'd like to turn it over to Tim Groulx and Ben Reierson. Tim is our solution architect under Digital Workplace, and Ben is our mobility lead and developer extraordinaire, coming to us all the way from Australia. So thank you, gentlemen.
Thanks, Kathrine. Thank you. Hi.
Okay, so I will expand a little bit on what Kathrine was just talking about in regards to our digital operations practice. And so really digital operations is what we call IoT. And so really for us, again, we focus on all sorts of industries industry verticals, and we're mainly focused on industrial IoT instead of, say, IoT in regards to consumer devices, et cetera. And so really what we're trying to do when we lay out digital operations is to remove the manual and even sometimes paper-based operations that are still at work out there in today's workforce. And we're really looking to bring the information that is available in these devices that are sometimes locked away in these factories and or within closed ecosystems from the operators, right? So for instance, what we're looking at here today is a little simulated factory floor, and this uses an Allen Bradley programmable logic controller. And Allen Bradley is run by Rockwell Automation, great company, outstanding products with a long history of industrial automation and excellence in that space. But as we all understand, companies are interested in kind of keeping their own ecosystems growing, et cetera. And so companies like Rockwell and Siemens and others really kind of focus on selling their own suite of products to manage the data and information that is available within these manufacturing and other industrial use cases. So what we're really trying to do is unlock the data and the information and the insights that's available within these closed ecosystems and pull the data out from these legacy devices, which have oftentimes been in production for years and can stand no downtime, and again come from closed ecosystems. And so we're here to liberate the data and allow people to gain insights and also interact with a mobile device directly with the manufacturing or other industrial devices.
Right, yeah, because I really think about this in this scenario that we're talking about as the marriage and the merger of these worlds. There's these stuff that's been around for a really long time. We don't want to change it. We just want to kind of make better use of it. We want to take today's technology, the phones that we have in our pockets, and of course Xamarin, and then the feature of the power that we're getting from Azure IoT, the predictive analytics we can do, the machine learning algorithms. So we're going to show all of that. We've got some cool demos. First, we wanted to kind of talk a little bit about how we got to this demo. It's been kind of an interesting journey. I think it started with you getting a bunch of hardware given to you for some reason.
Yeah, there's actually a particular someone out there in the crowd that came to me last year and kind of gave me all this equipment and said, hey, can you get this running within a few days before a conference last year? And I'll have to admit that I failed in that objective, and I did not get everything up and running. And there's numerous reasons for that. One, I had never actually wired together a PLC or anything, but also the initial solution that was built around something like this was, kind of less modern solution, I'll say. And so they were using technologies such as OPC, which is a standard protocol that was developed in the early 90s in conjunction with Microsoft and other industrial automation leaders. And so the solution was using, kind of legacy OPC. Now OPC has a new stack called OPC UA, which is .NET, and they've actually just released a .NET stack, which is really cool. But the original solution was using DCOM-based OPC, and so the travel of data went from the device to an OPC server to an OPC client, then to a C++ console-based application, which consumed the data from the client to push it up to Azure SQL database.
All right, so not exactly the most modern.
Not the most modern solution.
So we started talking about like how we could bring this to the tools that we like to use, and I always, being the mobile guy, kind of think how I want to do this in an app. I want to talk to these devices. I think it would be really cool. And we saw as we started researching the space that there was plenty of people using .NET, and most of this is a Windows world, and there was a lot of Windows services and stuff that was consuming this data, but it was stuck a little bit in the past. I mean, they hadn't kind of come into the whole portable class library world yet. We reached out to a couple of the big players, and Open Automation Software came back and said, yeah, we'd love to work with you. This is something that we recognize that we'd like to do. And the great thing is they moved really fast, and we worked really hard to kind of get this ready for this conference. And they ported like what was essentially like a 20, 30,000 line SDK. Like the SDK is very complex, and some of the stuff that's important about it is how it can communicate directly with at the driver level with some of these devices that maybe don't talk OPC, for instance. So long story short, like we've got there. John from Open Automation Software is here. He did most of the coding on that. And it's you know, allows us to bring it in, and they also added Azure IoT Hub support, which we're going to see. And yeah, I mean, Open Automation Software, by the way, has been around in this space before. I think they called it IoT, and they run their software monitors like the nuclear reactors on the U.S. submarines and like millions of data points a second. So yeah, some really powerful stuff. So I know we want to make up a little bit of time because we started late, but so we'll get to the demos as fast as possible.
Yeah, so anyway, so what you can see here is a look at a manufacturing plant, right? And you can imagine by seeing all of these robots, the conveyor belts, the amount of motors, sensors, devices that are at play in a complex environment like this. I mean, literally into the thousands of devices that are each sending, you know, transmissions of data down to the nanosecond at times. And so when you're dealing with, you know, the scale of devices and data that we have here, then, you know, you really need a robust and scalable platform like Open Automation Software. And so,
yeah, I mean, we would have loved to have brought one of those robots, but it didn't fit in the overhead. But we did bring essentially a factory assembly line, and while this looks kind of, you know, like it's a fun toy. It's really cool. Like, and it's and Tim is the one that kind of put it all together, and it's really sweet. But like, the important thing is that gray box in the background. That's the quote unquote boring part, but that's the most real, because that's the actual Allen Bradley logic controller that would be used at the kind of factory we saw the picture of.
exactly.
So this is the architecture now.
Yeah, so this kind of leads into a diagram of the architecture that we're dealing with. So over on the left, lower left side, you can see on the very left, again, we're dealing with Rockwell Automation Allen Bradley programmable logic controllers. So we have an Allen Bradley MicroLogix 1400 with a 1762 analog controller and a 1762 digital controller. These are what, you know, send signals to and from these, you know, fancy robotics that we've got here, which is our simulated factory floor. And so kind of the important thing here, as we've mentioned, these are systems that have been in place for years, if not decades, and, you know, really, they're kind of hands-off, right? You can't come in and directly touch or turn on or off these systems to put a solution in place. So the solution that we have come up with is that we are able to deploy Open Automation Software onto an IoT gateway, such as an Intel IoT gateway, and, you know, really have a very small footprint at the device site. And that allows us to, you know, come in and very quickly basically have this software running on an Intel gateway, plug the gateway into the device site network, and within half an hour we can be connecting to these, you know, standard industrial automation machines, pulling data, sending data, and actually controlling the operations through mobile devices. And so, you know, so once we've actually connected to the devices with Open Automation Software, then really we're sending the data in two paths. And so as you can see, it goes up to Xamarin applications, and really the idea there is that you've got a factory floor worker that's got his mobile device on him. He doesn't have to be connected to the internet. He's, you know, on wireless with the local LAN that the OAS service and the Allen Bradley machines are on. So, you know, even in a highly secure, closed environment, you can have people that are pulling data and getting real-time updates, along with the ability to control these devices directly, no internet connection. The second path is going up to Azure IoT Suite, and particularly as well as porting their SDK over to Portable Class Library, Open Automation Software has also built in a direct connector to Azure IoT Hub, which enables us to stream the data up into IoT Hub, you know, through the IoT and Cortana analytics suite of products. blob storage, machine learning, streaming analytics, Power BI, etc. So it really opens up everything that Azure has to offer.
All right, so should we actually show some code, show some demos?
Yeah, so let's get away from PowerPoint and come in here. And first off, we're going to start off with just the stock open automation software UI. And as you can see, there's a lot going on in here. So our goal ultimately with the mobile apps and everything was to streamline this whole process. But a little background on how kind of the device side connectivity works is that you create drivers, right? And so you create a driver to connect to your industrial device, such as the Allen Bradley unit there. Open Automation has built-in drivers for standard protocols such as MQTT, Modbus, Allen Bradley, Siemens. Allen Bradley and Siemens are the two leading PLC manufacturers in the world. And what they've also built into their suite now is the ability to connect directly to Azure IoT. So you can see this driver is pointing to our Allen Bradley unit. You define, the driver, the IP address, the processor type, etc. Okay, and so what they've done for us to enable getting data up to Azure IoT is, again, built in this driver. And it's really pretty simple, right? And that's the beauty of this, is they have this really robust industry scale, industrial scale service that can connect to and stream data to IoT. And it's very simple to configure. Basically, you need, okay, let's reload the portal. So basically, you need the IoT device ID, you need the IoT Hub connection string, and the IoT Hub URL. And so actually this, we get to show off a little bit of what Microsoft has released recently. And so within the IoT Hub, they have now added a device management capability, which eliminates the need to have an extra application like the Device Explorer, or to create your own application to view and manage devices within the IoT Hub. So you just click on devices. You can see I've got my little list of devices. I've got my machine station device. So I can come in here, I can get my connection string, my device ID, etc., which is what I need to configure this connection to IoT Hub. Okay, so once I have the driver up to my IoT Hub, I can come in and configure tags to send data. And so I'll just briefly kind of talk about what a tag is. It's a very common and standard industrial term for what represents a thing, right? So a tag represents a sensor or a motor or a device. And in this case, with our simulated factory floor, we've got accelerometers, conveyor belt motors, drilling station, milling station, etc. So basically every little thing that you see is a tag. And so, a tag gives you the information about what that thing is, right? The data type, the address, or where you would get the data from. This accelerometer data is coming from a simulator. And so you define your tags, you create your connections, and then in order to configure it to stream data.
Yeah, because so far everything is exactly how it would have been and has been for maybe decades, right? These exactly. Sensors aren't new. The data, the way they're connected via tags, all that stuff isn't new. But what is new is what you're about to do, right?
Exactly. Yeah. All of that is industry standard. Pretty much everything operates on tags, and so what we're doing is just connecting to these tags through the drivers that I showed you connecting. And now it's as simple as, once you get your connection string and define that driver, you can come in here, connect directly to Azure IoT Hub. I can tell it I want to write the data continuously, which basically means anytime a value is updated, it streams it up to Azure IoT right away. So before I actually kick this off, I will kind of talk about how we're getting that data and processing it into blob storage within a storage account in Azure IoT. And so basically, again, we've got connections and to IoT Hub. We define our IoT Hub endpoint that we're going to use. In this case, the messages, events, device to cloud endpoint. We define a storage connection string, a service bus connection string, and then it leverages event hubs and the event processor host to push that data into Azure Blob Storage.
Right, so the idea here is that we're going to use a console app to show this, but this would be probably a Windows service that you'd either deploy on-prem or in the cloud in Azure that would be doing this extra processing for you and moving the data around. But we're just going to kind of show that the streaming does, in fact, start happening.
Yeah, and so this is actually data that I had clicked before and was queued up in my IoT Hub. So it's kind of a little anticlimactic because you already saw data moving through there, but basically I create this connection, I apply changes, and it's instantly moving that data up to Azure IoT Hub. Now you can see that it's slowed down to the 1 time per second that value is being updated. And again, just continual stream of data up to IoT Hub, very reliable, very secure, based on Azure IoT security. So this is how we get data up into Azure IoT.
Then what do we do with it?
Yeah, exactly. What do we do with the data once we get it into Azure IoT? So, okay, it helps if I sign in. So what we do once we get the data up into Azure IoT Hub, again, is that we're leveraging the suite of services with IoT Suite and Cortana Analytics Suite.
Should we take the tour?
No, let's not take the tour. Let's just go jump right into it. Okay, my experiments. And so basically, what we're working on, again, in trying to improve the efficiency, the performance, knowledge, and insights of digital operations, and one of the main things that we're targeting is predictive maintenance. And so as you saw that we're collecting accelerometer data, which gives us vibration information, and we've got this data, we created a data set that goes back over time, and so we can actually look at the accelerometer data and model when a device is going to fail. And you'll see a little more later when Ben starts showing the application how that manifests in being able to notify and take action on preventative maintenance before there's an actual breakdown of the production line. And this is really important because a stoppage in production at an auto manufacturer or something like that can literally cost millions of dollars for a single day in lost revenue and others.
Yeah, this stuff gets really interesting because the predictions it makes, these algorithms are taking not just the data that we're feeding up, but it can cross-reference it with other sources of data, weather or temperatures and the rest of the production line or the predictions and the actions it says to take can be really unintuitive and yet very accurate.
Exactly.
And so yeah, it's worth listening to the machines.
Exactly. Yep. Okay, and so this is just a quick little view of Power BI. We've taken that data, we've created some graphs and charts. I can kind of look across the data here at a glance and see that, oh wow, in May and September and December, we had a major drop-off in production, right? And so then I can correlate that with, okay, we actually had unscheduled downtime in May and September, which will account for why we had the drop-off in production. And in December, we can see that there was actually just less scheduled time for the production line to operate due to the holiday season. So, just a quick view of how we get data streaming up into Azure IoT. We're able to, perform machine learning. We're able to create Power BI dashboards, et cetera, and surface those over the web and also into Xamarin applications.
Yeah,
And
yeah. So let's.
So
you mentioned something about Xamarin. Is that relevant?
I think people are interested in that. So.
Oh, all right. Well, let's check that out then. So let's switch back to the slides real quick because Tim's going to do a couple of little adjustments here. So when we started thinking about, well, what could we do with this? And we had a short period of time. As I said, we got the PCL for the great folks of Open Automation. They got that into our hands. We said, well, how fast can we throw together an app, and what can we do with it? And what we were thinking about is the use cases around, essentially the plant manager, the assembly line manager, kind of trying to untether him or her from the desktop, from that really complex interface that's really kind of overkill for a lot of the scenarios that are relevant to them, and create something that was really focused, had a great user experience, but was still extremely powerful and takes advantage of the native power on those devices. So while there are certain things that you can do over the web, what we were talking about is being on-premise connected directly to these devices, getting real-time data, real-time analytics, and being able to actually control them directly. And we were able to do it. So I started with a Xamarin Forms application. I'll be honest, there's not going to be that much crazy new about how I did that. That's one of the cool things is I use all the out-of-the-box capabilities, defined my UI in XAML, did my data model, and then hooked up to the SDK. So it looks like we're ready to pop back over. So I'm going to be showing this, and I'll show here that we've got Visual Studio open, we've got our Android emulator. I'm going to be showing this in Android, and as I was just saying, this is a Xamarin Forms app. I've got my views, got my data model. I've only got the Android one, but since it's Xamarin Forms, it would run on iOS and Windows and stuff too. So I'll try opening up the app here and just kind of show you what we're looking at. So it's essentially a task-based metaphor that we're going with, and it'll kind of lead us through what we're going to do with it. But the first step being that we need to actually configure this hardware. So the idea, the story here is, okay, we've had this assembly line running for a long time. It's a workhorse. We can't be taking it down just so that some, say, data scientist can write some algorithms. So what we're saying is, okay, well, we've installed Open Automation software on a server, and it's ready to be configured with my assembly line, the assembly line manager. And I'm sent this task, and it has an attachment which is a CSV, where all the tags are kind of defined, that we know are on this. But I'm going to go out there, and I'm going to actually verify. I'm going to inspect the hardware. I'm going to make sure, yes, these sensors look like they align with the actual hardware I'm looking at. I'm going to set my IP address of my server. And what we can see here is what Tim's done is he's actually cleared out all the tags. So there's nothing defined in there. We're actually basically starting from scratch as if it had just been installed. And now the idea here is we can just load this configuration, and it'll actually send that CSV configuration up into there. And what we see is 23 tags added. And if I go back over and refresh, our fuel tank production line tags are all installed, and they're actually all active already and reporting values.
I just wanted to call out really quick that this is really cool, right? Because as you can see, there's a lot of tags, and if you kind of look at the tag configuration screen, there's a lot of options for what you have to do to configure these tags. So to be able to have a predefined, standardized CSV that Ben can load in the click of a button to configure your environment.
I wouldn't really want to be doing this myself manually, even though this application is clearly a beautiful material design, it's kind of overkill, as I said, for a lot of use cases. So if I back out and said, okay, well, now I've done my configuration, let's go validate it. What I should see here, and actually, so that's showing that it's not connected yet. Let's hit this reconnect and see if we get live data coming in. Sometimes this takes a little bit to connect, but what we're looking at here is all of our tags, and they're kind of aligned with the order of the factory. So let me actually see if our networking will cooperate with us. Let's go back in, see if we connect. There we go. So we've connected, we've registered interest in all these tags, and we're seeing green, which means now we're getting good quality data from OAS, and we're getting our vibration, like Tim mentioned, we're actually using simulators for the accelerometers, so we're seeing those changes because obviously there's not much vibration going on down there. And then the little circles on the right are meant to represent the motors, and when they're running, you'll see them actually turning. Now, before we actually start this thing up, which I know we're all excited to do, I figured we might look at some code, which hopefully you also find interesting. So, I was going to go into the code and like go line by line and just look at it, and then if I wanted to compile it and run it and deploy it, it's kind of slow. Then I saw the keynote today, and I was like, workbooks, that's amazing. Like, maybe I can do that. And so I spent a couple hours trying to make workbooks work, and while it is an awesome product, it turns out that there's a bug in it right now, that on Windows, it doesn't load up the assemblies that I was trying to import, and they were like, yeah, sorry, actually, that part only works on iOS and Mac right now. And they were very apologetic and very, very good at researching it for me. But then I realized, well, why don't I just use the Roslyn REPL, which I don't know about you, but I kind of forget about it a lot. And it's actually pretty cool and useful. And so I'm going to hop on this bandwagon of doing like the live coding REPL stuff. So let's see if I can actually make this happen. So first of all, though, what I am going to try to prove is even though we're not going to be coding directly against Android, this is still the PCL version of the SDK that I'm going to use. And to prove that, I'm going to take the reference that's directly in our project here and import that and code against it. So the first thing that we need to do is actually bring in our SDK. So we've got our file. Now we're going to say we want to use it. OK, so what we need to do is new up a server object. I'm going to maximize this. And that's going to be of type OPC systems data. So now we have our server. Didn't have to give it any arguments. Pretty easy to interact with. And we just want to register our interest in some tags. So how do we know what tags we want to do? Well, we'll look at the configuration, and we'll say, well, let's say we want that accelerometer we've been talking so much about. So I'm going to take the full path of this, which includes the group name, stick it in here, and then include the .value, which means tags have a ton of different properties that you could be interested in. The value is kind of the one that we're interested in at the moment, right? So if I add that, OK, I've added it. Now I've said, OK, I want to hear about events, but then I need to do something with them, right? So what I need to do is subscribe to the value changed event. And the way that this works is it's going to come in with 4 arrays of values. The first one is the tags. Then we'll have the values themselves, and then we'll have the qualities of those, and then we'll have the timestamps for each one. And as Tim mentioned before, these things are tracked down to like the clock tick essentially. And then we want to loop through these values. And essentially what's going to happen is every time this fires, we're going to get a batch of all the changes that happened since the last time it fired. And as I said, this can scale to many, many, many per second. Basically, we could probably just overload this laptop and start it on fire with how many updates would come through, which hopefully we aren't going to do. So we're going to loop through this guy, tags.length is what I want, I++. All right, so then what are we going to do with that? Well, I think we're just going to write it out. And we're going to say we want to see the tag, which should be the name of the tag. And then I'm going to ask you to forgive my old school string concatenation. It still works. I don't know why everybody is so obsessed with all the new syntactical stuff. It seems fine to me. I don't know. All right, so it likes that. So as soon as I hit enter on this, we're going to subscribe to the event. We should start seeing the values. If they're changing, we'll start seeing them print out here. And there they are. So they'll start. And of course, what we're doing in the app is we're subscribing to like 20 tags all at once, and we're updating our data models as that comes through. So now the challenge is I've got to type while it's doing this. It's not like oh God, OK. All right, so that stopped. So what about if we want to change a tag, write a tag? So in this case, I'm going to use the sync write tags method. So this is essentially now I'm going to start taking control of this production line through the SDK. And in this case, I want to change. We have one very special tag called the PL start motor that kind of is the thing that tells the whole production line to start going. And again, I'm going to do value, and I forgot that in this case, it actually takes in an array of strings. So you can write, many tags at once. And then we have to give it an array of values, which in this case, we're just going to say true. Turn it on. All right, are we ready? So right now, you can see that over here, the value is false. So once I hit enter on this, not only should it change, but the thing starts running. So now it's true, and don't worry, well, we got to see it. Don't start it yet.
Oh, sorry, I was anxious. I wanted to see it run.
All right, there we go. So, yeah. Thank you. So this is our perpetual motion machine. Basically, the idea is we've got our little fuel tank. He's coming onto the assembly line. It's a brand new fuel tank, very happy. He's getting milled now, and then he's getting drilled. I mean, that's the phrasing. Okay. And then it all starts over again, right? So pretty cool. So let's go back to our app. And I wonder if this thing actually stayed connected. It did. So now you can see that conveyor belt is turning. It's going. And let's put it on there, put our fuel tank on there. Let's see if we can follow it through the assembly line on the app.
Each one of those turning knobs represents the motor or sensor turning on or off.
Yeah, pretty cool. So you can see like that, it's almost, if you sat here and you watched this and you saw like from the time that conveyor belt starts to the time that you're seeing it in the app is basically less than a second. Like it's practically real time. And that's one of those things about being a native app that's really cool. But we can go farther. And this actually, by the way, I have a screen. I can start and stop the production line from here. But it's cooler to do it from the command line. And then this is our real-time analytics. And again, this is where we're getting into, wow, our availability is so bad, we're in the negative. But anyway, so you can see that now that we've restarted this, while it was sitting there and the production line was starting, it was doing really bad. And all of our metrics were going down because we weren't producing anything. But now that we've started up again, it's able to calculate our rate. And you can see that starting to go up. So the whole time that we've been talking, it's been updating this graph here for us. And now we're starting to bring our quality back up, our availabilities back up, and we're calculating that it looks like we are going to hit our shift targets. These are sync fusion controls, by the way, Xamarin Forms controls. And just a shout out to them, like it was really easy for me to bring these in and wire them up to our data, and you're getting animated value changes. It's really easy to see what all this stuff means. And yeah, I think it works really well.
Looks great to me, Ben.
Yeah, thanks. And I think we actually managed to come back around on the time. Don't know that we have much time for the Q&A, but we can try. And then, yeah, we'll be around if you want to ask any questions. But thanks, everybody.